Welcome to the Appendicular Skeleton PowerPoint. This lecture is going to be used on both the lecture exam and the lab exam. Lecture exam will ask more about the textual stuff on this PowerPoint, and the lab exam will be using the illustrations from this PowerPoint, and you will be able to label those yourself on the lab exam. So, what is the appendicular skeleton? Well, it's where you find your appendages. This includes the arms and the legs. So that's what we're going to focus on today. So we'll start with pectoral girdle, which is going to be this girdle here. It kind of goes in a circle around your pectoral region. And then we'll go to the pelvic girdle, which is your pelvis, and that connects to your lower appendages down here. So the shoulder girdle, also called the pectoral girdle. This is going to be on the upper body, and it's going to be made up of two bones only. These two bones are the two clavicles and the two scapula. These two are going to be found in this picture right here: clavicle, clavicle, and then scapula and scapula. Those are the only two types of bones that are going to be found within the pectoral girdle. This pectoral girdle is able to bind to the humerus to make the shoulder joint. I want you to notice that you have the clavicle here, you have the scapula here, it's your shoulder blade, and it binds to the head of the humerus here. Notice that the humeral head only interacts with this opening on the scapula. This is called the glenoid cavity. We'll talk more about that when we talk about the scapula bone. So pectoral girdle is going to be this bone bound to the scapula, and it gives us a place to create a joint for the upper appendages. We'll start with the clavicle. The clavicle has a superior view and an inferior view. So this will be the top view of the clavicle. This is the underside of it, the inferior view. You have two ends of a clavicle. One is called the sternal end. It's a little bit more nubby. It has a flat side to it here. And then you've got the acromial end. This is more like pancake shaped. It's a little bit more flat, less blunt. Just like the name states, these names will tell you where those ends of the clavicle bind. The sternal end binds to your sternum. The acromial end binds to the acromion, which is found on the scapula. So these clavicles are going to provide attachment sites for muscles that are found in the pectoral region. The clavicles will also hold the scapula and arms laterally, and it'll transmit compression forces from the upper limbs to the axial skeleton, because remember, your axial skeleton is your head, neck, your trunk, which includes rib cage and your sternum. If you take note from the last slide, the clavicle has a direct joint with the sternum. So the clavicle, which is part of the appendicular skeleton, directly creates a joint with the sternum, which is part of the axial skeleton. All right, this is a great illustration for lab test question. It has a lot of labels on it, and this is going to be the posterior view. We are going to look at an anterior view as well, but let's start with the posterior view. So this is the back of the scapula. What I want you to know from this is two big things in determining whether a scapula is a right side or a left side. Anytime you see this bone here, this part of this bone, we call this the spine of the scapula. The spine is always posterior. If you notice on the anterior, there is no spine. So this is the anterior. The other thing I want you to notice is where the acromion is located. The acromion will always be pointing laterally. That means out towards where the arm is supposed to attach. So this is the middle of your back, the medial portion. This is the lateral side where your arm attaches to. Anytime you see the spine, it is posterior, and wherever the acromion is, that's going to be where the humerus attaches to. The key thing here is to see if you can find what is the posterior side of the scapula, and once you identify the posterior side, whatever side the acromion is on, that is the side of the scapula. So if the acromion is on the right side of the bone, like we see here, this is a right side scapula. A few key labels is, again, acromion. We've got the coracoid process. We've got the suprascapular notch, which is this notch right here. The superior angle, the spine, like we already labeled, the medial border, and the lateral border. You'll get a better image of the glenoid cavity in this next picture. This opening here, where the humerus normally binds to, is the glenoid cavity. And that glenoid cavity would bind to the head of the humerus like this, and that humerus would come down this way. So make sure you're able to label a scapula and tell me if it's a right side or a left side bone. The next bone we're going to cover is the humerus. So we looked at the scapula and we saw that the head of the humerus binds into the glenoid cavity of the scapula. So the humerus itself is the first bone of the arm. It is a single bone. There's not any other bones that run alongside it. And it has two ends, a proximal end and a distal end. Remember, the word proximal means closer to the core of your body. Distal means more distant, away. So if I just draw here for a moment, the head of the humerus going down, and then you'll see what I'm drawing in just a second. And then you have the radius, and you have an ulna, and you have your carpals, and you have your metacarpals, and then some phalanges. So in terms of proximal and distal, this way on the bone, so this side of it that's closer to your scapula, your rib cage, that's called the proximal end. This part here that makes up your elbow, that's the distal end. What I need you to know is what is found at each of those ends. So at the proximal end, which we covered in the last few slides, you have the humeral head here articulating with the glenoid cavity of the scapula. The distal side of the humerus, which is here, has what's called a trochlea and a capitulum. These are two structures that are found on the actual humerus bone. These two structures articulate with the radius and ulna, and I'm going to show you a picture of that right now. Here is the head of the humerus, and this is going to be, and I'm going to kind of draw a line here, up here is the proximal end. Down here is the distal end. So this is the part that attaches to the scapula. This is the part that creates the elbow joint. The capitulum is this rounded head-looking structure, and the trochlea is this kind of bumpy, jagged-looking structure. Those are the two pieces that interact with the bones of the forearm, which are these guys, the radius and ulna. This illustration will be used on a lab exam. It is a beautiful illustration, very clearly labeled, and almost all of these labels come from your lab list. So be sure to know how to label this bone and how to tell me if it is a right side or a left side bone. Now moving down past the humerus, we have those two bones, the radius and ulna. Those make up the forearm. The ulna is more medial. So remember, proper anatomical positioning is a person standing face forward, palms facing towards you. Lateral is this way, medial is this way. So the more medial bone is going to be this one. That is your ulna. The more lateral bone is this one. That is your radius. And again, let's look at it here. More medial is the ulna. Lateral is the radius. These two bones articulate with each other here and here. So the ulna has a lot more features to it. I do love testing on this bone, especially these guys up here. So I'm going to show you an illustration in a second, but for right now, let's go through these facts. The ulna has something called a coronoid process. And if you see, let me go ahead and erase this and this. The coronoid process is labeled on the right side of that ulna. It is right here. The coronoid process is a ridge that sticks out anterior of the ulna. This coronoid process is continuous with this smooth backing called the olecranon. The coronoid process and the olecranon, these guys bind in to the humerus. So they bind right here to the humerus. The other thing I need you to know is that the distal end is separated from the carpals, which would be here, your wrist, by fibrocartilage. And if I could just kind of show you where that fibrocartilage is going to be found, it's right in here. So fibrocartilage is found between the distal part of these bones and the carpal bones, which are your wrist bones. And then the radius, this is more lateral, and the proximal end is going to articulate right up here. The distal end articulates here and right over here. So let's look at that articulation really closely. This bone is the humerus up here. This is the radius, that is the ulna. I want you to notice where they're actually articulating. This is important for you to know. The head of the radius articulates with the capitulum of the humerus, and the coronoid process of the ulna articulates with the trochlea of the humerus. There's this third structure on the humerus called the medial epicondyle. This doesn't articulate with either of these bones. So make sure you know the names: capitulum, trochlea, medial epicondyle, head of the radius, and coronoid process of ulna, and tell me how they articulate. For example, the head of the radius articulates with what structure on the humerus? You would say capitulum. So everything that I'm saying out loud is actually written in text. So be sure you know these articulations for your lecture exam. And then for the lab exam, be sure you know how to label the images of these bones. Because again, these are the pictures that I'm going to use for your first lab exam. All right, this is a beautiful picture. Why? Because you can see all of the structures that are on the proximal part of the ulna. These four structures I always ask about on the lab exam. This ridge here is called the olecranon. This smooth inner sliding opening is called the trochlear notch. The part that sticks out, coronoid process, and this smooth surface is called the radial notch. The radius binds here. So be sure you know this picture. Now moving on to the bones of the hand, we've been using the word carpal a whole lot. The carpal bones are what actually combine the bones of your forearm with the bones of your hand. So the carpal bones, there are 8 of them, and they're arranged in rows of 4. Your job, and of course it's in red and bold, is to know the names of the bones and be able to label them. So here are the names of the bones. Again, 2 rows of 4. The proximal row are these 4, and the distal row are these 4. It's going to be easier to teach this if I just show it to you. So here is the bone. I want you to notice they're always labeled because you always have to know like which hand it is and which view it is. There's an anterior view of the right hand. So right now, if you're sitting here watching this lecture, take your right hand, face the palm towards you. This is how you're looking at the bones. This is going to be the easiest way to learn it if you actually just do it on your own hand. So this right here, let me go ahead and just circle it, and I will label it. This is the proximal row. This is the distal row. So the proximal row starts with the scaphoid bone. I'll number them for you. So 1 is here. 2 is the lunate. 3, triquetrum. And then 4 is the pisiform. So 1, 2, 3, 4. The next four is the trapezium. Then you have the trapezoid. I know they're similar words. Make sure you know the differences. Then the capitate. And lastly, the hamate. So 5, 6, 7, 8. Know the names of these bones and the order that they're found in. There's a lot of actual mnemonics that you can find online. Go pick one and have that help you memorize these guys. All right, so we've done the pectoral girdle, we've done the arm, we've done the forearm, and we've done what I need you to know for the hand. Now we're going to move down to the pelvic girdle. Again, this is a beautiful illustration, very clear, that you can label for the lab exam. So to clarify, this whole thing is called the pelvic girdle. This whole pelvic girdle is formed by 2 os coxae, or coxal bones. This here is one coxal bone. This here is a second coxal bone. These coxal bones, and I'm going to change my color now, are made up of 3 fused bones. And the fused bones don't have clear lines of distinction, so I'm just going to circle them for you. The ilium, the ischium, and the pubis. Those 3 bones have fused to make one coxal bone, and then 2 coxal bones come together to make the pelvic girdle. This is also called a girdle because it's an attachment site for your legs. Your legs actually attach to these open structures. These look like almost like ball joint-like structures, and we call them acetabulum. Everything on this illustration is on your list. Be sure that you're able to label this for the lab exam. Here is one coxal bone, and this is going to be a lateral view, so you're looking at it from the side. This is the opening where the acetabulum actually is and where the femur binds to. So now we're talking about the bones of the leg. The femur binds here. When people get hip replacements, this is what they're fixing, replacing, or adding synthetic products to. The top is called the iliac crest. It is the crest that is formed in the ilium. You have the superior iliac spine, and if there's a superior one, there's probably going to be an inferior one too. Inferior iliac spine. You have a posterior superior iliac spine and a posterior inferior iliac spine. So just by these names, you know that this is the posterior, where your butt would be. This is your anterior, where your genitalia would be. So I would say 70% of these labels are on your list, not all of them. So please make sure you have the list open in front of you when you're studying this. Now, how can you tell if a pelvis comes from a male or a female? Well, there's 2 major things that we're going to be looking at. Number 1 is going to be the sacrum. So the sacrum is this bone right here. Coccyx is this bone right here. For females, the sacrum is much more curved and the coccyx is more movable. It's less rigid. Can you guess why we would have a more curved sacrum and a more flexible coccyx? Well, for childbirth. It must be a little bit more flexible and it must provide a larger area for fetal growth. For males, it's a lot more rigid, a lot more straight, and really it's because they don't need the area or the volume for growth. The second way is to look at this angle here. This is called the pelvic inlet. The pelvic inlet for females is much wider, again, because females need more space in the pelvic cavity. For males, it's much more narrow. If you notice, this is kind of the shape of an upside down heart. So much more narrow. So those are the 2 main ways. That sacral curve and the angle of the pelvic inlet. Moving down to the bones of the femur. Again, this is a beautiful illustration, very clear. We have a femur. You got the head. You've got the lesser trochanter. What's not labeled on here, and I'd like you to label that, is this guy here. This is called the greater trochanter. You've got the medial epicondyle and the lateral epicondyle. Notice that the medial epicondyle is always going to be on the same side as the femoral head. This femur is the heaviest and strongest bone in the body. The proximal end, which is up here, has the head of the femur articulating with the acetabulum of the pelvis. So if you saw on the last illustration, the head of the femur binds into that open region. It creates a ball socket joint. The distal end articulates with the tibia. So the tibia kind of looks like that. But we'll see this articulation in a slide or two. So let me just go back. This is an anterior view of the bone. This is a posterior view of the bone. Again, here we have the head, lesser trochanter, greater trochanter, and then we have the medial condyle and lateral condyle. And you're wondering, oh, Professor, you just named this an epicondyle. Epicondyles are on the sides of the bone. They're less smooth. The condyles are only on the posterior. They're these guys here. They're the smooth moving surfaces that actually create the knee joint. They're called condyles. Again, the medial one will always be on the same side as the head of the femur. So that femur is going to articulate with the bones of the lower leg, primarily the tibia. So the proximal end of the tibia, so if I just draw the femur, and here we have the tibia. So the proximal end, which is this end of the tibia, and let's say your foot is right here. The proximal end is going to articulate with the femur to form the whole knee joint. The distal end, it's made up of a structure called a medial malleolus, and it's going to be on this side, and you'll see that in just a moment. And it's going to create the joint we know as the ankle. The second bone that's going to be there is going to be called the fibula. It does not actually contribute at all to the knee joint, but the distal end, and it'll be kind of in the back here, contributes to the ankle joint. So the two bones of the lower leg include the tibia and the fibula. So this illustration actually shows a lot of what the previous text said. So this is an anterior view of the right side lower leg. So this bone here is the tibia. This bone here is the fibula. I want you to know that the tibia is always more medial than the fibula. So if I had a foot drawn on here, it would go that way. So the tibia has a few structures I want you to know. Tibial tuberosity. You've got what's called the medial condyle. And if there's a medial one, there's probably going to be a lateral one too. These ridges are called intercondylar eminence. And then you've got this important structure called the medial malleolus. If you look right now at your ankle, the medial part of it, you'll see kind of a bone ridge sticking out. If you touch it, it's pretty hard. That's your medial malleolus. It's like right there. Attached to the tibia is the fibula, and it attaches through what we call the proximal tibiofibular joint or the distal tibiofibular joint. These joints are immovable. They do not move. In between the tibia and fibula, you have this connective tissue called the interosseous membrane. It connects the shafts of these two bones together. On the fibula, you have this structure here called the head of the fibula, and that's more proximal. And more distal, you've got the lateral malleolus. So again, look down at your ankle, but now at the outside part of it, and you'll see that there's a ridge there, and that's your lateral malleolus. So the lateral malleolus is on the fibula. The medial malleolus is on the tibia. Make sure you know this illustration. Again, this is going to be a good one to use on the lab exam. That's as far as we're going to go on the appendicular skeleton. Be sure that you're studying this PowerPoint for both your lecture and your lab exam and using your lab list as a reference. If you have any questions, please don't hesitate to email me.